Hey guys, welcome back to the channel. Today's video will be the continuation of the series we started earlier, and today we'll be looking at a quadratic equation type of question. So let me start by reading the question. The root of a quadratic equation of the form ax squared plus bx plus c is equals to 0 is given by the formula x is equals to minus b plus or minus square root of b squared minus 4ac over 2a. For there to be a solution, there are 3 or 4 conditions to be satisfied. The first question is we have to write a Fortran program to determine the roots of the quadratic equation of the form above using the if statement or construct. Second question is to open an input file and store the following values a, b, c to test the 4 conditions or situations. Your program is to read these values from your input file. You have the values there, and the third thing we have to do is to open an output file and write the results in it, like the roots in the output file. So let's start by opening our Fortran file. Fortran, yes, and let's name our program quadratic equation. Let's give it a name, quadratic equation. Then the next thing I want to do is to define our variables. The variables we have so we're answering the first question, which is to write a Fortran program to determine the root of the quadratic equation of the form above using the if statement or construct. So the form above is ax squared plus b x plus c is equals to 0, and we know that to get the root of the quadratic equation of that form, the formula is this formula. And we also know that a quadratic equation has two solutions, which will be x and y in our case. So we'll be solving for 2 solutions. Yes, so let's define those variables. So I'm going to give it real, because we might have a value of maybe 1.0 something, so on like that. So let me just give me real. We have b, we have c, and we have x and y, which are the two solutions. So the next thing is, okay, let me put a comment here as saying defining variables. To write a comment, we're just going to put a exclamation mark in front of what we want to comment out. So the next thing is, yes, before we move on, let's look at the conditions. The question said for there to be a solution, there are 3 or 4 conditions to be satisfied. I've already written the 4 conditions down here. I'm going to be looking at them. The first condition is a must not be 0. A must not be 0. If a is 0, this one will cancel out, and we'll have a linear equation which is bx plus c is equals to 0, and we don't want that, and that will be giving us just one solution. The next condition is b square equals 4ac. If b square is equals to 4ac, we'll be having real and equal roots. We can also have a condition of b square greater than 4ac. For this condition, we'll be having real and distinct roots. And the last one, this will give us an imaginary root. B square is lesser than 4ac, and we don't want imaginary roots, so we're going to learn how to put those conditions into an if statement or construct, like what the question said here. We're going to learn how to put it into an if statement or construct. So let's move back to our Fortran file. I want us to create a logical data type. So a logical data type is a type of data type that accepts logical values. When I talk about logical values, I'm talking about true or false values. That you put your conditional statements in. You assign your logical data type to conditional statements. So that's what we're about to do. We have four conditions we want to assign. So we're going to write 4 conditions. Let's put condition 1. Let's copy this. let's say condition 2, let's say condition 3, and condition 4. Yes. So for condition 1, I'm going to say first condition is a should not be equal to 0. Condition 1 is a, and the way we write not equals to is use the forward stroke with the equals to, not be equals to 0. Condition 2 is equals to second condition is b square is equals to 4ac. B square, or our exponential is double multiplication sign, is equals to double equals to 4 another bracket 4 multiplied by a multiplied by c. Condition 3 is equals to, is similar to this one, so we're just going to copy this condition 2 and paste it here while changing this operator sign to is greater than, right? Yes, greater than 4ac. And condition 4, close this up. Condition 4 is also similar to the last two. You just have to put less than sign there, less than sign there. Just close this up. Next thing we're about to do is to write our if statement on construct or construct. So we'll start by writing an if statement. If the first condition we want to assign to the if block is this condition, which is a must, it must always be there, like it must always return true, that a is not equal to 0. Why? If a is equals to 0, this equation will turn into a linear equation, like I said earlier. But these other equations, these other conditions can return true or false, because an equation can return, okay, maybe b square is equals to 4ac for one equation, b square might be greater than 4ac for another equation, or b square might be lesser than 4ac for another equation. So like I said, this number one condition is a compulsory condition. So if that condition doesn't pass, it's going to return something that, okay, this is condition did not pass, so this is so that's what we're going to do. So if condition 1, that means if condition 1 returns true, that means if a is not equal to 0, then we're going to turn another if statement here to validate the next conditions, because we're going to be going through others. So let me just comment this out so it's not confuse us. But if condition 1 doesn't pass, that means if a is equal to 0, I'm going to put an else statement here. Then we're going to tell the user that, okay, a should not be 0. Let's put into brackets 0. Alright, I made a mistake here, so I'm going to remove this then. Then is not meant to be there. Then is just going to be there if we're starting with an if statement or else if statement. So yes, so if condition 1 passes, we're going to move on to our next if statement. But if it doesn't pass, that when I say if it doesn't pass, that means if this condition returns false, that means a is equals to 0. The condition is a should not be equals to 0. If a is not equal to 0, it's going to return true. It's going to return true. But if a is equal to 0, if a is equal to 0, it's going to return false. And if it returns true, it's going to continue with this block. But if it returns false, it's going to come here and print this out. Let's test it. Let's test it by let me just say print a is not 0. I put this here and when I run the code, you should see a is not 0. That means this one is running. I wanted to write a is not 0, but if a is equals to 0, you see here. Let me run it again. We'll see a should not be 0. So I hope that you should understand that. Let me clean this up and let's continue with our code. Let me clean this up again. Next condition we want to move to is these two conditions, the condition 2 and condition 3. So we can write condition 2 dot or condition 3. If b square is equals to 4ac, or b square is greater than 4ac, we're going to move on to calculate this the formula. Rather, we're going to move on to calculate this formula. So let's put this formula into code as well. Well, like I said earlier, it is a quadratic equation. We are expecting two results, x and y. So this plus or minus, we're going to separate them into two. So plus is going to go for x and y is going to go for negative. Minus is going to go for y. When I put it in code, you understand better. Our first thing we're going to write is then x is equals to minus b. Start by minus b. We're going to put in a bracket, minus b plus, like I said, plus, we're going to assign plus to x, plus into brackets. You see a square root here. I'm going to do a square root there. I'm going to put into another bracket. So I'm going to say square root. To write square root, we're going to use this to use the square root function. I'm going to just write this square root as sqrt. Then put into bracket again b square minus 4ac. So let's put that into brackets. First put b square, don't forget the exponential, double multiplication sign, minus another bracket, 4 times c. Then yes, it's going to do the square root of it. Okay, I think that's correct. So I want us to be careful while we're doing this, because it can get really confusing with the amount of brackets, the multiplication, the exponential. You can get confused and end up getting the wrong result. So you should always do a double check. I also make mistakes when I'm doing assigning brackets to stuff like this. Then another bracket for our division divided by 2a. Then let's put everything in. Okay, I think it should be okay like that. Yes. Then y is equals to, is the same thing. We just have to change the operator in the middle to negative operator to minus. So yes, then we'll print out x and y. Print, say the roots. Okay, let's just print out x and y for now. Some people might be wondering, what are we going to do with this condition, the last condition, b square, that why did we b square is less than 4ac, that why did we not use it when we're using the two conditions, a condition 2 or condition 3? Like I said earlier, condition 4 is going to give us, let me go back to our notepad. Condition 4 is going to give us an imaginary root, a complex root, an imaginary root basically, and we are trying to look at real roots and not imaginary roots. So if a case comes up that b square is less than 4ac, we want our program to do something, because it is very obvious that it's probably going to come up. Like, look at this value now. Look at this third value. This 1 minus 1 and 1. If you do the b square minus 4ac, we'll see that b square is obviously lesser than 4ac. So once that case comes up, we want our program to return something and tell the user that set of values that you add brought about imaginary roots, and that we won't be able to produce a result for you. So just move on to the next one. So let's go here. Before our end if statement, I'm going to write an else if condition. Then we're going to put condition 4. We're going to print, that's if b square is lesser than 4ac. We're going to print the set of values produced an imaginary roots. Rather. Okay, so I think we've answered question 1. This is our if statement or construct. So what question 1 was telling us is that we should just put this equation or this formula into code while using if statements to satisfy these conditions, and I think we've done it. Here. Let me move this down, close this up as well. So moving on to the next question, we are to open an input file and store the following values a, b, c to test the 4 conditions or situations. Your program is to read these values from your input file. So let me input. Okay, so let me open this place. I already created a text file in the same folder as my Fortran file. Remember, your text file must be in the same folder as your Fortran file. If it's not in the same folder as your Fortran file, you might experience errors of the compiler trying to find the folder that the file you specified in your Fortran code. So let me input the values into this place, and so the first value you have here is 1 minus 3 and 2. So let me put that in 1 comma minus 2 comma and 3. Next set of values you have is 1 minus 2 and 1. 1 minus 2 and 1. Next set of values 1 minus 1 and 1. Next one we have is 0, 2 and 3. 2 comma and 3. So let me save that. I named the file quadratic value text .txt, and I'm going to open that file in my Fortran code. So let me just comment this out and say opening quadratic values.txt in Fortran file, or let me just say opening quadratic value txt. So to open a file, we're going to use this open statement, then open. I'm going to assign a variable to it to be able to locate the file that we're talking about in the when we're trying to pull something from the file later. I'm going to specify the name of the file. What's the name of the file? The name of the file is quadratic values.txt. Remember, it should be in the same folder as your Fortran file. So this is another point where we hit a do loop. I'm going to have to do a do loop. Why do we have to do a do loop? The reason why we have to do a do loop is we have to run through all these values, then run through this value, and return each value after every calculation. Return each result after every calculation. So how are we going to do that? Let's start by opening a do loop. Our index is I, as you all know. Let me specify index integer. I'll say I. Also need some values as P. Let me just say PQ and R. These are the variables that are going to pick the values in the quadratic values of text. Then start, we have 1. How many lines do we have here? We have 4 lines, so that's 1 to 4. Then next thing we're going to do is to read. We're going to read from the file we opened, the quadratic values.txt. So let's read. Say read. Don't forget we already assigned 1 as the variable we want to identify the file with. So I'm going to say 1 comma asterisk. Then we're going to say I'm going to read P, Q, and R. So A should be equals to P, B should also be equals to Q, and C should be equals to R. And from that, we also want to put all this our if block and our conditions into this place. And let's indent this properly. So let me save this and let's run it and see the values we are going to get. So okay, so I just realized that I made a mistake when I was inputting this first value in. It's meant to be -3. That's why we got a set of, if you look at the terminal when we ran the code, it sends the set of values produced imaginary roots as the first value. So let's effect that change, -3 and 2. Going to -3 and 2. So I'm saving the txt file again and we're going to run the code again to see what we're going to get. So I'm running it again. Okay, our first value got us 2 and 1 as the roots. The second one got 1 and 1 as roots. The third one returned the set of values produced imaginary roots. Like I said earlier, it was going to produce it. And the last one said our a should not be 0. When we look at our quadratic values.txt, we can see that what p is taking and p is equal to a is 0 as a. So that's why it returned a should not be equal to 0. So let me clean up our results and so that our result can be more readable. And I say okay, we can write the set of values, comma a comma b comma c. Okay, the roots rather the roots of values a comma b a comma c are, say x comma y. Then what we can write here is that set of values with this set of values comma a comma b comma c then comma, then let's close this up, produce imaginary roots. Then we can say for values a comma b comma c, and let's save that and run it and see. Oh sorry, let's run this and see what we're going to get. Yes, you can see that the first set of values, the root of values 1 -3 and 2 are 2 and minus and 1. The root of values 1 -2 and 1 are 1 and 1. The set of values 1 -1 1 produce imaginary roots. a should not be equal to 0 for values 0, 2, and 3. So that answers question 2. So the last question is we should open an output file and write the result in it. Okay, so instead of printing it, we want to write our results in that file. So how do we go about that, or how do we do that? So let's come to our Explorer here, then create a new file. We'll say output, we'll name it as output quadratic.txt. Remember, it should be in the same folder as your Fortran file. So to write into a file is different from opening or reading from a file. It has the same concept, but it's quite different. So how do we go about that? We open the file first. The file we want to give it assign to. Then what's the name of the file? We'll write the name of the output file. The name of the output file is output quadratic.txt. So let me just write that there. Output quadratic. Remember, quadratic.txt. Next parameter it takes is status. Status means, have you created the file before? Is the file present in the folder, or whether you just want to create it. We're going to write old because we've already created the folder. And the next parameter it takes is the action we want to perform, which is write. And the last one it takes is position because we want to add values to the file, so we're going to put in append. Instead of our print statement that we have after every code, we're going to change the print to write. Then yes, we're writing into the file. I'm going to input the assigned variable that we assign here, up here, which is 2. Put it here, comma, then star. Yes, star. Yes, then the roots of the values a, everything should work. So let's change it for this as well. Right, let me just copy it to save time. Then also for this last print here. So let's save it and run it and see what's. So at the end of everything, I want our code to print done. Let me just write here so I will know, okay, done. So we got done. It returned done rather. Then let's check our txt file, our output.txt file. We can see that in our output quadratic.txt file we have the root of the values 1, 3. We have the same thing we got here when we printed the results. So that's, by getting that, we've answered the last question. And yeah, that's the end of the video. If you have any questions, let me know in the comment section below, and